Hi, my name is EASYLY. I'm a third year medical student, and I am here to tell you to subscribe to Sir Majesty Easy World, where science is fun.
The whispers in the morning.
Okay, this is still balancing of chemical equation. This is the part 2, continuation of the part 1, and I guess you have watched the part 1. Remember I told you that in chemical reactions, atoms are neither created nor destroyed, but can be transformed from one form to another. To prove that atoms are not destroyed during chemical reaction, that is why chemical equations must be balanced. So during chemical reaction, atoms are rearranged and bonds holding atoms are actually destroyed and new bonds are formed, but the atoms themselves are not destroyed. So you must make sure that the number of atoms on the reactant side must be equal to the number of atoms on the product side. So continuation from the part 2, we were considering a reaction between acidified potassium heptaoxodichromate 6 and a reducing agent, which is hydrogen sulfide, to give us, like I told you, the two metals will displace the hydrogen in this acid. So potassium sulfate will be formed plus chromium 3 tetraoxosulfate 6, then plus water, that's the hydrogen displaced, then plus sulfur. Now, in this equation, for you to balance this, you must, I told you, you can start with hydrogen or oxygen and know what you are capable of doing. So, when we consider these reactions, at least sulfur is 1 plus 3. This 3 times 1 here is 3. So, 1 plus 3 is 4, plus this is 5. So, we will start from, and sulfur here is only but 2. So, we have to adjust some things here. So maybe we try making this one 4 to compensate. So because if you say now this is 4 plus this one, it gives you 5. And when we put 4 here, what it implies now is that oxygen will now be, on this side, will now be 4 times 4, this is 16, this is 7. So oxygen will now be 7 plus 16, which will be 23. So then oxygen here will be, this is 4 plus 3 times 4 is 12 plus 1. So we have 4 plus 12, which is 16. So we have 17. So we are still 6 oxygen less here. So we are having 17 here, but here we have 23. So which means we have to adjust this to get us to 20. So if you put 6 here, 6 will not, 6. Let's assume we put 6 here so that we have, this is 4, this will still be 22. So this will not balance the equation. So we need to put 7 here. Yes, exactly. So when we add 7 here, oxygen now is 23, I guess so. Yeah, this is 12 plus 7 is 19 plus 4, 23. So we have balanced oxygen. So we have done the major job. We can now take a look at hydrogen here is 14. The hydrogen here is 8. So I must do something to suit the hydrogen here. So we have 14, but we have 8. So you say 14 minus 8 should be 6. So which means, what must I multiply 2 by to give me 6? So here should be automatically 3. So what we have now is 2 times 3, which is 6. I'm now checking for hydrogen. If hydrogen and oxygen balances in any equation, we have done the half of the job. So 2 times 3 is 6. Then we have 2 times this is 8. So 8 plus 6 is still 14. So we have settled hydrogen and oxygen. Then other atoms remaining, what about sulfur? Sulfur now is 7 because this is 4 plus 3. But sulfur here is, this is 4, this is 3, 4, and 5. So what must we do to make this? If we make this one 2, it is extra 1, so this should be 3. So that when you say 3 plus 3, that's 3 times 3, 6, plus this one is 7. So sulfur is balanced. Chromium is already balanced because this is 2, this is 2. So this balances this equation. So that is it. So work with oxygen first and hydrogen in each case. Then I'll give another example. Let's see a reaction between sodium hydroxide plus halogen, like chlorine gas. Remember, this reaction can proceed in 2 ways depending on the concentration of this sodium hydroxide and the temperature at which the reaction is occurring. Meaning, the products that can be gotten from this reaction, there are 2 possible things or 2 possible sets of products that are gotten. I'll tell you that. If the sodium hydroxide is concentrated and hot, we will get sodium chloride plus a powerful oxidizing agent, sodium trioxochloride 5, plus water. But if the sodium hydroxide is dilute and cold, we will get sodium chloride plus the domestic bleach you use for washing, that is sodium oxochlorate 1, otherwise known as sodium hypochlorite, still with water formation. So let's try balancing. As usual, sodium, how many here? We have 1. Sodium here is 1. Let me not use the part I used in part 1. So that step is for beginner, and I hope by now you have upgraded a bit. So your job is to count the left hand side, the right hand side, then do justice to that. But that should be in our part 1. In our part 2 is assumed we have advanced a bit. So now we have sodium is 1, but here is 2. So it is trying to show us that sodium needs to be added to here. But let's calm down first. Sodium here is 1. Sodium here is 2. Then what about oxygen? Oxygen here is 1. In the reactant side, oxygen is 1. This is the only oxygen. But on the product side, we have, this is 3 plus 1. We have 4. So which means the number that will balance this equation, we must start with 4 here. It is a must that 4 will start here. Then, if 4, look at the secret. If 4 do not balance this equation here, don't try 5. Do you know why you shouldn't try 5? Assuming you put 5 here, we now have 5 hydrogen atoms. But when you come here, how can you make this hydrogen 5? There is no whole number that will be multiplied by 2 to give you 5. So, I said earlier, if hydrogen, or I'm saying it again, if you come to balancing equation, and hydrogen one side is 1, the other side is 2, that place it is 1, and you know that you can't multiply it by 2. Don't use odd number, use even number here. So, I said 4 will start this. How? Because oxygen is 3 plus 1, and this is the only species bearing oxygen, which means I have to try 4. But if 4 refuses to balance this equation, I won't try 5 because there is no way I will make, there is nothing I will multiply to a good whole number that I will multiply by 2 to give me 5, which means I will use even number. So let's go with 4. If here is 4, automatically we have settled oxygen. But obviously 4 cannot balance it, but because when you put 4 here, hydrogen is now 4, which means you have to put 2 here. Therefore, putting 2 here have increased the oxygen. We have now, this is 2 plus 3, which is 5, which cannot work. So it is automatically, if you have experience, it is showing that 3 will work here, such that this becomes now 3 times 3, 3 times 1 for oxygen, plus this 3, which will give you 6, which means automatically 6 enters here. And that gives us the first edge. So if 6 enters here, it means we have 6 sodium atoms. Now checking here, if I should put a higher number here, let's assume I put 5 here, so that I'll say 5 plus 1. I will increase the oxygen by 5. So it's advisable I put 5 here and leave this way. Let's check if the equation is balanced. Chlorine here is now 2. Chlorine here is 5 plus 1. Chlorine here is now 6. So what must we do to 2 to make it 6? We have to put 3, such that 3 times 2 is now 6. So with this, I'm very sure the equation is balanced. So when you check sodium, 6, 5 plus 1, 6, oxygen is 6, 3 plus 3, 6, hydrogen is 6, 3 times 2, 6. Chlorine is 2 times 3, 6. Chlorine is now 1 plus 5, which is 6. That balances the equation. Then when you come.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Her Majesty Easy World Science.
And do you know the best part?
It
makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science in your entire life.
Another thing about Her Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously there's love in sharing.
Thank you! See you there.
Come down here, to balance the equation, you still, this one might be a bit. Okay, we start with that sodium. Sodium here is 1 and 2, so we put 2 here. 2 here shows that oxygen is now 2, and oxygen is 1 plus 1, which gives you 2. So the equation is okay. Oxygen is now okay. Hydrogen is now 2. Hydrogen is already 2. Chlorine is now 1 plus 1, which is 2. So these 2 I added here have settled this equation. So in balancing chemical equation, always try to settle oxygen. If there is oxygen there, then settle hydrogen. On doing that, you invariably get the equation balanced. So that is it for balancing of the chemical equation. I might take another example. Remember, you are advised to use whole numbers, but you can use half to balance equations. But it's advisable you use whole numbers so that while doing your stoichiometry, like now, the stoichiometry of this reaction should now be 6:3:5:1:3. You can easily do your calculation well without using decimal points. Okay, I'll take another example. So let's see if we have a reaction like this. In the production of another reaction that may take another dimension is aluminium versus H2SO4. It can give us, definitely this must come out, aluminium tetraoxosulfate 6. Then if this acid is concentrated, it's going to give us H2O and then SO2. That should be the gas produced. But if this acid is diluted, it will be a displacement reaction whereby aluminium plus H2SO4, the aluminium will just displace this particular hydrogen here such that this salt, aluminium tetraoxosulfate 6, will be formed, then plus hydrogen gas. This one is displacement reaction, just like here you see. Remember, if this is replaced with potassium hydroxide, it is the same thing. Okay, then I'll take the first one, or rather, maybe let me balance this simple one. This one here is Al is 1, but Al, that's aluminium, is 1 atom here, but on the product side there are 2 atoms of aluminium. So you simply rush and put 2 here, simple, to balance off the aluminium. Then hydrogen here is 2, hydrogen here is 2. Then you check again, hydrogen, yeah, then sulfur, or rather we take a look at oxygen. Oxygen is 3 times 4, 3 times 4, which is 12. But oxygen here is, okay, yes, because this 3 is for sulfur, automatically there will be 3 here. Because of this sulfur in brackets of 3. Then when you check oxygen here, oxygen now is 4 times 3, which is 12. So this equation is balanced if we do something to the hydrogen. So hydrogen will also take 3. And this has settled the whole thing. So this is it. But this one might take more challenging work to be done. So, but like I told you earlier, you just use sulfur. Let's use this sulfur first. We have 3 sulfur here. plus here we have 4. Therefore, anything that will balance this equation, anything you want to write here must start with 4. Reason is because we have gotten 1 times 3, which is 3 atoms of sulfur, plus this one here, which makes it 4. So you must start with the number here, 4. Then when you make this one 4, remember you'll be now forced to put 2 here. Sorry, put the same 4 here. Let's try going with the 4. So putting 4 here, automatically there should be 2 here because of the Al2. Then if 4 comes in here, 4 will also come in here. So let's check oxygen. If oxygen is balanced, our job is half done. Okay? Oxygen here is 12, then oxygen here is 12 already. 3 times 4 is 12 already. Okay, sorry, oxygen here is 4 times 4, 16, sorry. Then oxygen here is 12 plus 4, which will give you, is 2. Is what? Okay, sorry. Oxygen here is 12 plus 4 plus 2. Very correct. Thank you there. There is an oxygen here. Thank you, engineer. So we have 12 plus 4, 16 plus 2. So we have 18. It means that we must adjust this place. So we try exactly 6. Because we are 2 higher. So let's now see what happens. 4 times 6 is 24. Then if we put 6 here, we should be mandated also to put 6 here. And when such is done, this is 12 plus now 6 plus 12 plus 6 plus 2. I think we are there. 12 plus 6 is oh, sorry, then there should be, because of the sulfur here, we put 6, so sulfur is 6, then we have 3, so there should be 3 here. Yes, to compensate that sulfur, which is 6 here already. So that means our oxygen here now is plus 6, yeah, and we have 24. So 24, 24. We have gotten oxygen, and it means our job is half what? Done. Okay? Then, if hydrogen and oxygen balances, other ones are simple, and as we're looking at them, they are all balanced. Aluminium here too, aluminium here is also 2 atoms. Hydrogen is 12, 2 times 6, hydrogen is 2 times 6. Oxygen is 24, 4 times 6. Then, here, remember this bracket, this 3 governs only the thing in this bracket. This bracket is, if I will expand it, it means S3O4 times 3. Meaning S1 times 3, then 4 times, meaning S3O12. So, but by the formula, this is the way it's reduced. So, 3 times 4 here is 12, plus 6, I think we got it. This is highly balanced. So, that is it for balancing chemical equation. Like I said in the beginning, that balancing chemical equation is something that you need to use your discretion. Remember to book for your own private classes online if you are still finding it difficult, but learn to use your discretion. The secrets I gave is that you have to write it out, divide it into reactants and products, bring out the numbers in the equation, then try to balance it. Then do not touch the molecular formula of a compound while balancing equation. Meaning, I said it in the part 1, H2O is water. If I want to balance oxygen, I am not allowed to put 2 in front of this oxygen, because if I do put 2 here, it's no longer water. Like now, when oxygen refuses to balance, if I change this SO2 to SO3, SO2 and SO3 are different compounds. You cannot be balancing an equation and you create a new thing, different thing altogether. Someone is trying to tell you to sit well so that you don't fall and eventually destroy you. That is not the way out. So don't touch the subscripts. Rather, you are allowed to touch the coefficients. That's the moles in balancing chemical equations. So God bless you and remain majestic. I cannot do without you. Don't forget to subscribe, share, and expand this easy world of science. You can also get me at Sa Majesty Easy World Science channel here on YouTube. Then get to my site at www.easyworldscience.com. God bless you.
Much love, remain majestic.